So this is a differentiation question, and the first part is to just find dy dx. So for this first one, it's already arranged into a format that we can differentiate. So we have the number and then the letter, the number, the letter, and so on. So there's no x's on the bottom as the denominator or anything else. We can go straight in with differentiation. So for this one, I've got 1, if I just write out the question first, 1 over 45 x to the power of 5 minus 2/3 x cubed plus 6x. So when I differentiate that, that gives me dy dx. And I'm going to multiply the power in front, so that gives me 5 over 45. And then I'm decreasing the power by 1. I multiply the power in front, so that gives me 6 over 3, because it's 2 times 3, x squared, and then multiply by the power and reduce it by 1. So rather than writing x to the 0, there's no x's there, so I can actually just take that off altogether. And then I can simplify that down, so that gives me 1/9 x to the power of 4 to x squared plus 6. So I can simplify it down at the end, just using my calculator. So the second part, there are 2 points on the line, A and B. So A and B are somewhere, so they could be here and here, or here and here, anywhere at all, where the tangent to the curve is equal to -3. So that suggests that they're somewhere on this section and somewhere on this section, because the tangent is the gradient, and for it to be a negative, it would need to be going in this direction. So it must be somewhere here and here, which means I can now check my answer afterwards. So when I'm doing this, I'm going to first of all set the gradient equal to -3. Okay, so we know that the gradient, which is 1/9 x to the 4 minus 2x squared plus 6, my previous answer, is equal to -3. And if you'd written whatever your previous answer was equals to -3, then you would have got that method mark. We're now rearranging that and trying to solve it. So we can actually do that straight away on the calculator. So if I go to my so 1 over 9 my laptop is very slow here. So 1 over 9 x to the power of 4 minus 2x to the power of 2 plus 6. And then I'm going to plot the right hand side of my equation, which is -3. And I'm going to graph these two. Okay, and if I just change my window here, -5 to 5, and my y-axis, let's do this here. So I've changed my axis, and now you can see what this looks like. So we're looking for the two intersections. So we can now do second function calculator, and we're looking for the intersection. So just going to scroll across to one of the solutions. So one on the left hand side, one on the right hand side, and my solution there is -3. So x is equal to -3. And if we look at the graph there, that does make sense, that it would be somewhere between -4 and -2. So we're now going to do the same thing again, but this time on the solution on the right hand side. So we're just scrolling across, selecting one graph and then selecting the other. And this time the solution is +3. So x is equal to +3. So I have two solutions, one at -3 and one at 3, which makes sense on my graph.